Hello students. So in this lecture I'm going to discuss about the addressing modes of 8086 microprocessor. So what is addressing mode? As we all know, in case of 8085 also I told you about the addressing modes. So what is addressing mode? Again I am explaining. So as we know, every microprocessor we give some instruction. Now that instruction, what is the function of that instruction? That instruction performs a specific operation on a specific data. So every instruction means they are going to perform certain duty or certain operation on a specific data. So the operation that they're going to perform on a specific data means for performing that operation they need some data. So that data is called operand. So addressing mode means how we going to specify the operand in an instruction is called addressing mode. For example, there are in 8086 microprocessor we have 8 addressing modes. They are register addressing mode, immediate addressing mode, then we have this direct addressing mode, register indirect addressing mode, based addressing mode, indexed addressing mode, base indexed addressing mode, and base indexed with displacement addressing mode. So the addressing mode, so in we have this 8 addressing modes in 8086 microprocessor. So in register addressing mode, what will happen? The operand is actually the content of 8 or 16-bit general purpose register. That is how we are specifying the operand in the instruction. Suppose for example MOVAX CX. This is an instruction of 8086 microprocessor, and what does this instruction do? It will move the content of CX register to the AX register. So what is the operation? Operation is moving the content from the source, that is from one register to another register. And what is the operand? Operand is the content of the register CX. So in register addressing mode, if the operand is the content of the register, or we can say if the operand is specified in terms of content of the register, then we will say it is the register addressing mode. So here both the source and destination, source means from where the instruction is going to get copied, and destination, source means from where the instruction is going to get copied, and destination to which place to which place that operand is going to get copied. Again I am repeating, what is source? Source is from where the operand will get copied, and destination is to which place the operand will get stored or copied. So both the source and destination should be registered. Like in this in this example also, add ALBL. So here also, as you can see, the content, the operand is the content of the register. Like what add ALBL instruction will do? It will add the content of accumulator low with the BL register, with the content of the BL register. So here the content of the register, here it is the content, here the operand is the content of the register. So in register addressing mode, operand will be the content of the register. Then we have the next addressing mode as immediate addressing mode. In immediate addressing mode, we specify the operand directly in the instruction. So in immediate addressing mode, the operand on which the operation is going to get performed, it will be mentioned directly in the instruction. For example, MOVAL 35H. So here the operand is 35H. As this instruction, what it will do? It will store this content, immediate content 35H, into the accumulator low. So whatever is the operand, if it is specified in the instruction, then that type of instruction will fall under immediate addressing mode. Now The remaining six addressing modes, they specify the location of an operand which is placed in a memory. So in the previous two addressing modes like register addressing mode and immediate addressing mode, we specified the operand either directly in the instruction or operand was the content of the register. But in rest of the operating modes, in rest of the addressing modes, what will happen, the operand, we will specify the operand's offset address in some or the other way. So as we know, the memory address of an operand consists of two components. So the starting address of the memory segment and offset. The 16 MSBs of the starting address of the memory segment resides in the segment register. As I've already told you that 8086 microprocessor, the memory associated with 8086 microprocessor is actually segmented memory. So in segmented memory, what we will have different segments like data segment, stack segment, extra segment, code segment. So data segment will generally store the operands. So in data segment, if this is the memory and we have this data segment at this point, then the starting address of the data segment, the 16 MSBs, the 16 MSBs of the data segment, the 16 MSBs of starting address of the data segment will be stored by a segment register, and the offset from where the operand will get copied from in the data segment, or you can say where the operand is residing in the data segment. So that offset, this is the offset. Offset means the distance of the operand address from the starting address will be called the offset. So and that offset will reside either in the base register or index register, or it may be given directly in the instruction. So what is happening in rest of the addressing modes, this offset can be specified in different ways, and depending on that we will have different addressing modes. So when an operand is stored in a memory location, how far the operand's memory location is within a memory segment from the starting address of the segment, I told you that is called offset, or you can also call it as effective address. So 8086, as I've told you how we make 20 bits, as I've told you, like in the data segment, if the operand is residing at this place and this is the starting address of the data segment, so this 16 MSBs of the data segment will be stored by the data segment register. And to make 20-bit address, what will happen, we'll add we will use 4 zeros to the left of this so that we can have the 20-bit address, and there we're going to add the offset, so we'll get the exact location or the exact address of this operand where the operand is residing in the data segment. So this part I've already explained in my previous lectures also, that is how we going to make the 20-bit address. Now this offset, the offset can be it can be specified in terms of displacement, base or index. Displacement means it is an 8-bit or 16-bit immediate value given in the instruction. Base means base means it is the content of base register BX or BP, and index means it is the content of index register SI or DI. Now the combination of these three address elements give 6 memory addressing modes. How? For example, the third addressing mode of 8086 microprocessor is direct addressing mode. In direct addressing mode, we mention the offset of the operand. Again, I am repeating, in direct addressing mode, we mention the offset of the operand directly in the instruction, as in the form of 8-bit or 16-bit displacement. So what is the offset? This is the offset. So this 8-bit or 16-bit displacement, or you can say the 8-bit or 16-bit offset only, this is the offset only. So this offset will directly be mentioned in the instruction, and what this instruction means, add AL 0301, and the 0301 is given in the form of is written within the bracket, within the square bracket. So whenever you see in 8086 microprocessor any data written within the square bracket means it is the address. If any data is written without the square bracket means it is the operand. So again I am repeating, in 8086 microprocessor, so in at instruction at AL0301, what is happening? It will add the content of accumulator low with the content of this address. So how we will get the actual address of the operand? By adding the starting address of data segment with the offset mentioned. Again I am repeating, by adding the starting address of data segment with the offset mentioned in the instruction, we will get the address of the operand, and that operand will get added with the accumulator low, and the result will get stored in the accumulator low. So what I'm trying to say is, in direct addressing mode, the offset of the operand will be mentioned in the instruction itself. The offset can be an 8-bit displacement, the offset can be a 16-bit displacement. So and one more thing that I was telling you, if in 8086 instruction you find any data written in the instruction without the square brackets means it is the operand, and if you find any data written with sorry, again I'm repeating, if you find any data written within the square bracket, then it is the address. It is the offset address, and if you find any data without that square bracket, then it is the operand. So I'm ending this class here. We'll continue with the addressing modes in my next lecture also. Thank you.